class! Welcome to our first video of Chapter 6, and this video is going to be pretty much all about angles. Alright, so first thing, if we go back to geometry class, we remember that an angle is what? It is one ray, two rays, and then it has something called a vertex, which is what? The vertex is the endpoint of both of the rays, alright? Now, what we need to understand and what we're going to care about now in pre-calculus is standard position. All of our angles, every single angle that we use, is going to have a vertex at the origin. That's one. And two, the initial ray is the positive x axis. Alright, so we'll see what I mean by that in 1 second. Alright, let's switch colors here. Okay, so positive angles, we know now that if we're going to have an angle, the vertex has to be at the origin, and the initial ray, the first ray, has to be going out in the positive x direction. Okay, so that's what I meant by the initial ray is the positive x-axis. So there we have it. What we need to know is positive angles go in counterclockwise fashion. Alright, so if I wanted to go, let's say, how about 200 degrees, positive 200 degrees? Well, I would need to do what? I would need to start here at my initial ray, and I would need to go 200 degrees in a counterclockwise fashion. So here, how far is that? That's 90, right? So 90 degrees. So we'd go past here, we'd go past here. This is 180 degrees. So 90 to 180, and then we'd need an extra 20 degrees, so maybe something like right there. And then what we would do is we would draw what we call the terminal ray. Why terminal? Terminal, end. Like at the airport, terminals, that's the end where you catch a plane. Okay. So we now know that positive angles go counterclockwise. Negative angles, of course, would then go clockwise. So what if I go negative 200 degrees? Well, it's the same type of idea. I have to start at the positive x-axis. But now what I'm going to do is I'm going to go negative 200 degrees. So I'm going to go back 90, back 180, and then back about 20. And I would draw my terminal ray, something like that. Okay? Hopefully that makes sense. If you want, you can say that this is negative 90, this is negative 180, if that helps. Alright? Okay. So now that we have an idea about what positive angles and negative angles are, where angles start, let's see if we can draw some of these other ones down in the next section. Alright? Excuse me. So as we slide down here, 45 degrees, this first one. Well, 45 degrees, we know that here, and this, get in the habit of this, every single angle should start at the positive x-axis, okay? So there's my initial ray. 45 degrees. Well, what do we know? We know that here, going straight up, due north, would be 90 degrees. Well, 45 is half of 90, so that means that my angle has to go directly down the middle, something like that. And I would show it using a little arrow to show that I went a positive 45 degrees. Okay, when we move on to the next one, again, initial ray. My terminal ray has to go negative 90 degrees. Well, negative 90 is straight down. Alright, so there's my angle, negative 90 degrees. And again, guys, I'm not doing a great job of showing this. If you need the help, you can always put in the measures, the degree measures, if that helps you. Okay, anything you need to do to help you is fine. Like we knew that this was 90 degrees, so that's why I knew that this was going to be 45. Alright, okay. On this next one, 225, let's see, go straight out to the right. And then 225. Well, I know I have to go 90, 180, and then let's think about this. 225 is between 180 and 270. And it's actually exactly halfway between, right? Because 45 more than 180. Perfect. So this is going to go halfway in between quadrants, or sorry, the x-axis and the y-axis here. So we're down here in quadrant 3. Again, if it helps you, you can label this to start. 90, 180, 270. That should hopefully help you understand that 225 has to be somewhere in this third quadrant because it has to be between 180 and 270. Okay? All right. Let's keep going. I'll try and speed up a little bit. I'm probably boring some of you guys. All right, 405. Well, 405 is greater than 360. So hopefully we understand that we have to go 90, 180, 270, 360. And now we have to decide where or how much more, I guess, is 405, excuse me, from 360, right? We've already gone the 360 degrees. Well, that's an extra 45 degrees, right? Right? So 405 minus 360, yeah, 45. Okay? So again, if I have my initial ray, and I go 90, 180, 270, 360, I need to go another 45, which is straight that way, 45 degrees, all right? And I finish my angle. So we know that it went one full rotation and then a little extra. All right? All right, 720, same idea. Initial ray, I go what? I go 90, 180, 270, 360, 450, 540, 630, 720. I'm right back where I started. So a 720 degree angle is actually just right back where we started at the initial ray. All right? Negative 120. Okay, let's think about this. We know we're going out to start, and then we have negative 90. So let's see. I go down 90, and then an extra 30. So maybe something like that. And I could draw my terminal, and I'd call it a day. All right, I know that I'm in quadrant 3 there because I knew that this was negative 90, this is negative 180, so I'd have to be somewhere between there. All right. Negative 315, same idea. Okay, I go negative 90, negative 180, negative 270, and then another 45, another negative 45, so something like that. And I draw my terminal. The thing that really distinguishes is that you notice the negative, I went around this way, rather than in something like A, where I just went 45 up. I went negative 315 all the way around. All right? And last one, 495. Okay. So, initial. 90, 180, 270, 360, 450, because I added another 90. So 360 to 450. 450, 495 minus 450, that's 45, okay? So another 45 would be halfway, something like this. And again, make sure to draw your arrow so we know what's going on. All right? Okay. Which of these examples show quadrantal angles? Well, if I tell you it's B and E, do you think you could come up with your own definition of quadrantal? If I tell you it's B and E, right here, B and E, those are my quadrantal angles. What do you think is true? Hopefully you said something about the axes, all right? I hope you said something about the axes. And really what I want you to understand is a quadrantal angle, the terminal ray must be on an axis. All right? Terminal ray must be on an axis. And why is that? Well, because the axes create the quadrants. Quadrants. Okay? So that is one thing that you can use to kind of help you remember. Quadrantal angles are when the terminal ray are on an axis. All right, which of the examples show coterminal angles? Coterminal angles, if we break this word down, like a co-worker, someone you work with, well, co means with, and terminal means end. All right, so we're going to look for angles that are with each other at the same terminal ray. Okay, the same terminal ray. Same terminal ray. And what do we see? Well, I see A, looks like this 45-degree angle, right? And then what else looks like A? A. How about D? Absolutely. A and D, and there's one more. Can anyone find it? G. Absolutely. Even though we write A as 45 degrees, D is 405 degrees, and G is negative 315 degrees, these are coterminal rays because they all have the same exact terminal ray. All right? Okay. So enough about that for a little bit. We're going to move away from degrees and we're going to learn a little bit about radians. All right, so this next page, just I guess a quick little review. We just worked on this, right? Degrees. We know that this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and if we kept going, this would be 360 degrees, right? And honestly, these can keep going and going and going and going and going forever. But the point I'm trying to make is we know that one revolution is how many degrees? 360 degrees. Okay, we know that. We've worked with degrees for a while now. Something that might be a little less common is when you work with radians. Okay, radians, we still start at 0. Notice I did not put a degree sign. Radians, no degree symbol. All right, that's your hint that you're in radians. If you don't see a degree symbol, then you should be in radians. And what we say here, guys, is that it takes 2 pi to get all the way around, okay? 2 pi. So that means that our revolution is 2 pi. All right. What I want to do, though, something that helps a lot is figuring out these other pieces. And hopefully you guys can understand that if it takes 2 pi to go all the way around, well, how much is it to get just halfway around over here? It's just pi, or 1 pi. And that should make sense, right? 360 divided by 2 is 180. 2 pi divided by 2 is pi. All right? And then after that, hopefully we can figure out, well, if this is 0 to pi, right, halfway around is pi, well, then this should be pi over 2, because we just have to cut this pi in half. And then let's think about this. If this is 1 pi over 2, well, we could write this as 2 pi over 2, right? 2 divided by 2 is 1, so you just cancel and get pi, which means this should be 3 pi over 2. And let's check. 4 pi over 2? Yep, 4 pi over 2 is 2 pi. All right, so what I want you guys to understand here in the big takeaway, pi equals 180 degrees. All right, pi is equal to 180 degrees. We're going to use that again, and really we're going to use this to help us draw by creating fractions. Okay, help us draw by creating fractions. This is like our home. This is what we need to start with at all times, and then we move from this to help us figure out how we're going to draw the rest of these down in the next section. Okay? Well, what do I mean by that? What I mean is, I know that I'm trying to draw pi over 4. All right, pi over 4. What I want to do then is I want to say, instead of just calling this pi over here, I want to call this 4 pi over 4, because I know I need to break it into 4 pieces. I need to divide it by 4. So if I need to take this, which I know is 1 pi, and split it into 4 pieces, well, what's the easiest way to do that? cut it here, cut it here, cut it here, and then you just need to understand what? You just want 1 pi over 4, which means if this is my initial, then this is my terminal. And I went positive. Okay? Hopefully that makes sense. On the next one, 3 pi over 2. Well, again, instead of writing this as pi, I'm going to write this as 2 pi over 2. Because then I know, well, this is 1 pi over 2, 2 pi over 2, 3 pi over 2. We already knew that one, right? Actually, from up above. So there's my initial. Here's 3 pi over 2. So there's my terminal. And then remember, we went that way. All right. How about C? Well, again, I want to split into thirds, right? I'm dividing into thirds, so that means I need to know that this is 3 pi over 3 over here. And that means I need to divide this top half, right? Because I know that's 1 pi into thirds. Well, this might not be beautiful, but it'll be something like this, or close enough, right? Those are about equal. And what? I want 2 of them, all right? So I have my initial, and then 1, 2. All right, so there's my terminal. And I draw my angle, arrow. All right, if we keep going, again, thirds. Again, we're in thirds. So here's 3 pi over 3. I'm going to split everything into thirds. Again, not the best, but it'll do. All right, 7 thirds. That means I need to go, oops, sorry, here's my initial. I need to go 1, 2, 3, 4, 5, 6, 7. And so now I know that 7 pi over thirds is actually the same as 1 pi over 3, right? 7 thirds pi, or 7 pi over 3 is the same as 1 pi over 3. Beautiful. All right, we're almost done here with this. Let's think about, okay, so we're going to split into fourths, so 4 pi over 4. So that means I want to cut it like this, like this. Draw in your initial. Once you have your initial drawn, you know you want to go 7 pi over 4. So 1, 2, 3, 4, 5, 6, 7. Arrow, terminal. Oh, that's sloppy, but it'll work. All right. All right, let's try a couple with negatives. It shouldn't change much. All right, we still want to split into thirds. We still know that this is 3 pi over 3, but now we have to know that we're going in a negative direction, so we're going to go down. So we want to split it into thirds again, but we're not going positive, we're going negative. So I just want to go negative 1/3, like this. So there's my terminal, and there was my initial, and we should be good to go. Negative pi, we really don't have much work at all to do here, guys. There's nothing really to divide. We just need to know that this is pi, so we want to go negative pi, which is over here, and we went down in a negative direction, so something like that. And then our last one, negative 2 pi over 3. Okay, so again, 3 pi over 3. We want it in thirds. Break it into thirds, and we want 2 of them, right? So if here's my initial, I want to go negative 1, negative 2/3. Something like that. All right. Now, just as a quick reminder, quadrantal, we remember our terminal needs to be where? Our terminal must be on an axis. So we're looking at B and G. And there you have it. All right, one more page, almost done. Not too bad, hopefully. All right. If you remember from the page before, we talked about how pi is always going to be equal to 180 degrees. All right, this is important. We are going to basically be using ratios to convert. If I have something in degrees and I want to convert it to radians, well, that means I need to cancel out degrees. So I'm going to multiply And if I want, again, to cancel out degrees, well, then I need 180 degrees to be on the bottom, and then pi would have to go on top. And hopefully that makes sense, right? Because this is kind of like over 1, and what's going to happen with these degree signs? They're going to cancel, you're going to be left with a pi more times than not in your final answer, and that's what we're looking for. Okay? Now, kind of conversely, or opposite, we know, I'm going to just get rid of this. I probably won't be writing rad. We know that we're going to want to cancel pi's, all right? Normally, our radian measures have pi's in them, okay? So that means that we're going to have to multiply, and we're going to want to cancel out the pi's. So that means that pi is going to have to go in the denominator, which means the 180 will go in the numerator this time, okay? Now, it's okay if you ever see, like in the book, let's put this back for a second, if it is radians, right? If there is a rad there, what it means, it's 180 degrees over pi radians, right? So what would happen here? They would cancel, just like the degrees are going to cancel in this one. Okay? Makes sense, I hope? We're going to practice right now, so hopefully we'll see what's going on. All right, so convert each of the following angles to radians, then state which quadrant it is in. All right, so 60 degrees. 60 degrees. We're going from 60 degrees, and we want to go 2 radians, so we need to cancel out degrees. So the degrees go in the bottom. All right, now let's see. Degrees cancel. What happens, we're going to have, and if you need to, you can put this over 1. You don't need to do it, but if it helps, do it. 60 and 180. Ooh, I can reduce that to, right, 1 and 3. 60 goes into 180 3 times. All right, so this is just pi over 3. Beautiful. Beautiful. All right, pi over 3. Good. Let's go to the next one, 150 degrees. Same idea. If you put it over 1 and you want to cancel degrees. All right, this one's a little tougher. I'm thinking that I can take out 30s. If I take out 30s, I'd be left with 5 and 6. Okay, yeah, 150 divided by 30 is 5, 180 divided by 30 is 6. Perfect. Okay, so 5 pi over 6. This, if you notice, guys, you're going to want to get pretty good with fractions. All right, we're going to want to be pretty good with your fractions. All right, nothing changes when they're negative. Same exact ideas. Let's see here. Degrees cancel. I believe if I take out 45, well, 90, yeah, okay. I can reduce this -1 and 4, okay? 45 goes into 184 times. 45 goes into 184 times. So, of course, -45 would go into 180 -4 times, all right? So, let's see here. We have negative pi over 4. We're good on that. Last one, 107. 107 times pi over 180. Degrees for sure cancel, but I do not know how to reduce 107 and 180, so my final answer is just 107 pi divided by 180. All right. If we move on to the next set, we're going to go backwards now. We're going to do the exact same thing, but reverse. So now, if I have pi over 6, I have to remember I'm going to try to reduce and cancel out pi. So now I'm going to, instead of doing pi over 180, I'm going to do 180 over pi. And this is exactly what we wanted, guys, right? We wanted to see pi's cancel, and now we know what? 180 divided by 6, what is that, 30 and 1? Yeah, 30 degrees. All right. If we do the next one, what do we have? 3 pi over 2 times 180 over pi degrees. What happens? Pi's cancel. 180 and 2 go to 90 and 1. But just remember, it's 3 and 90, so this is 270 degrees. All right, a few more. Negative 3 pi over 4. Okay, let's go back. Negative 3 pi over 4 times 180 over pi. Pi's are going to cancel. 180 and 4, we did this one earlier, that's going to be 45 and 1. And so now we just need to multiply negative 3 by 45. Well, you can either do that in your head, or you can remember, you can just say, well, 45, 90, 135. All right, so negative 135 degrees. All right, next one, 7 pi over 3 times 180 over pi. Let's see here, pi's cancel. Oop, I'm forgetting my degree symbol, sorry. 180 and 3 is 60 and 1. And then 7 times 60 is 420 degrees. That should make sense, right? 7 pi over 3. That, if we went back a little bit, I think we drew that one. Did we? Yeah, we did. We drew that one over here, and that went all the way around. So it makes sense that it's greater than 360 degrees. And then this last one, okay? This last one is something that I want to talk to you about on a couple of different fronts. All right? Please understand that there's no pi here, and that's goofy. I get it. But is there a degree symbol? No. This is in radians. All right, you need to be careful. This is in radians, and I know it because there's no degree symbol. So you need to be on the lookout for this. So that means that we're still going to do 3 times 180 over pi. Now, in this situation, is pi canceling? Absolutely not. This is not going to be a nice number. You're just going to do as much as you can. Well, 3 times 180 is 540, but it's still over pi. All right, so this is a nasty number, and I would leave it just like that. The other thing I want to actually do real quick with you guys, just because we'll probably ask you something like this at some point, is how would you graph something like this? If your measurement is 3 radians, well, what I would want you to do is I would want you to know that 3, well, if this is 0, right, we know that here's our initial at 0, and we know that this is pi, right? Well, pi is about what? 3.14. All right, so we would need to know that if we want to graph 3, it would just be a little bit before pi, something like that. All right, so that's one thing that I want you to be on the lookout and understand, that you can graph this even though it's not a nice radian number. This is doable. It is doable. All right, so there you have it, everything that you ever wanted to know about angles. Ugh. I hope you enjoyed this video. Can't wait to see you guys again. I'm excited for the new semester. See ya.